Distinguished Chair and Moderator, Air Marshal Anil Chopra, retired, former DG CAPS. Inviting our eminent panelists, Lieutenant General A.P. Singh, retired, former Director General A2AD, DGAD. Air Marshal Sanjeev Kapoor, retired, former Director General Inspection and Flight Safety. Inviting Mr. Vishesh Vatsal, CTO Skyserve. Inviting Ms. Sree Supranayi, CEO AnduraX. Inviting Mr. Raghava K, co-founder and CEO Sanyark Space. Our distinguished Chair and Moderator, Air Marshal Anil Chopra, retired, former DG CAPS, eminent panelists, distinguished delegates, ladies and gentlemen. A very warm welcome to the session, Deep Precision Fighting and A2AD Role of the Space Triad in Current and Future Wars, that examines how space-enabled systems are transforming current and future conflict scenarios. Our Chair, Air Marshal Anil Chopra, is a highly respected air power strategist and defense analyst, has been a leading voice in military modernization, aerospace strategy, and integrated airspace operations. His deep understanding of doctrinal evolution and emerging technologies makes him ideally suited to guide his critical discussion. Sir, we are very honored to have you chair and moderate this very pertinent topic session. But ladies and gentlemen, before I hand over to our session chair and moderator to carry forward the proceedings of the session, I have a very important announcement to make. Ladies and gentlemen, we have been informed Army Chief will be here at the venue at 6 o'clock, and we have to vacate for security protocol before he arrives, at least 10 minutes before. So we have a hard stop of closing the proceedings sharp at 5:45. And with that, I would now hand over to our chair and moderator. Over to you, sir. I would request if we could conclude by 5:35 so that we have some time for the closing.
Okay, good evening, everybody. I'm slipping in for Air Marshal Anil Chopra. I'm Air Marshal Sanjeev Kapoor. And we are straight away beginning with the future wars that will be started without a shot being fired. And this will all begin with disruption of satellites, denial of data, and collapse of precision. So I have a wonderful panel here with me, and we will, in the short period of time that we have got, we'll try and get to all these. We have Lieutenant General A.P. Singh. We have Mr. Vishesh Vatsal, CTO Skyserve, Ms. Sree Supranayi, CEO AnduraX, and Mr. Raghava K, co-founder and CEO of Sanyark Space. So I will throw this discussion open first to Lieutenant General AP for his comments.
Am I audible there? Okay. Is there? Okay. We are supposed to be talking about the deep precision strike capability. We are talking about the anti-access area denial capability, how they are, how they should be, and how the space can facilitate or enhance or bring us up to the level that we desire. So I'll focus on three issues of it. Firstly, the precision strike capability. What you saw in Ops Sindhu last year, the battle that we had about 88 and 89 hours, how the Indian Air Force targeted those bases of the Pakistan and how the whole Pakistan capitulated. So precision basically is your ability, your capability to see the battlefield, look at those high-value targets, ability to track them and to strike them strike with the aim of destroying. That's the precision strike capability. But this precision strike capability is not something which has just come up. If you look back into the history, post-Vietnam fiasco which United States had, they started looking at the precision strike capability then. With the onset of your satellites in 1970s, then onset of your GPS, then surveillance mechanism both on the ground and the air, they started coming up. So somewhere around 1980, the precision strike capability was developed by the US. What you saw in the Gulf War 1991, those 100 hours of war that in which Saddam Hussein was taken off. Even we saw in the Gulf War too. So that's the first point I'm trying to make, that the precision warfare is not something which has started now. That's the time Russians, let's admit that Russians are very good theorists. If you look back at in the Battle of Kursk or something, World War II, when the Germans were trying to overlap them, they developed a strategy, tactics, and they know the whole World War II turned around. So the Russians are supposed to be very good in theory. So they started working on the precision, how to counter the precision warfare capability of US. Because why precision warfare succeeded was basically it's a very simple, they got an uncontested environment. There was nobody to contest them. So that's how the concept of Retd strike complex came up. The Russians said we'll have a long-range surveillance capability, we'll have long-range weapons, and with that we'll be able to counter this thing. So as a counter to the precision strike capability, the Retd strike complex, or whatever you want to call it, the Russians started developing in 90s. And the same thing resulted in somewhere around 2008-9 with that anti-access area denial capability coming in, which we all now keep reading about how Chinese have developed a anti-access area denial capability against, in the Western Pacific, against the US now. So anti-access basically is that capability that you develop with the long-range weapons not to let the enemy come inside. And area denial is basically the short-range capability that you develop whereby you restrict the maneuver of those forces if they come inside. So now you see around Taiwan, the first island chain, second island chain that now they're developing, and how those long-range Chinese weapons are. Now it has moved very fast now. The Chinese are using that a combination of instant recce, that information warfare or intelligent warfare that talk about. Then all this, they have networked all that. And thereafter, so my understanding has been is somewhere around moment this anti-access area denial capability came up, the precision warfare that what US was exposing all the time, that has almost saturated now. So US had to move beyond that. And luckily, all this somewhere around 2011-12, that all these emerging technology have started coming up. I remember when I was doing my staff course way back in early 90s, we used to talk about RMA, IT, net-centric warfare. But all that now I'm finding is changed now. Now we are into, they call it RMA, artificial intelligence. You are using your AI, you are using your precision, your machine learning, robots, quantum security. So today the US now, if you read the last 2-3 years, the way US has started this thing, they have now come down to, I'm talking exclusive from the ground perspective today. The space has been talked about and the thing, but how the space is going to be relevant to the Indian Army's operations. The US today focuses on tactical operations, decentralized operations, all domain operations, multi-domain operations, what you call it. If you recollect the exercises that Air Force is doing now in the Alaska, Guam, and that kind, where, I mean, using satellites, using your 6th generation aircraft, and guiding the troops on the ground. So that's where now my understanding is your space comes in now. The space will provide us communication, where space will provide us PNT, that precision navigation, this thing. Space will provide us surveillance. So where today the theater commanders, the ground commanders, the need of secure, instant, I'll say communication, this thing. So that's where the space has become. Now, your warfare, what we talk about, multi-domain, means there'll be simultaneous operations in all the space. Other thing, my feeling now is that because of the long-range weapons which have now started developing now, long-range, extra-long range, so your space segment itself is getting segmentized now. You'll be fighting battle in the terrestrial space, you'll be fighting in the lateral space, you'll be fighting at the close to the ground. So there has to be different tactics, different operational plans, or different this thing. You have to get into now nitty-gritty of it. So these are my comments as far as that how the precision guidance or precision warfare or this is there. As far as Pakistan is concerned, you've seen now post that last year's Op Sindoor, they announced now that they'll have a Recce force. So they are looking at how to create a A2AD, that anti-access area denial, to the Indian Air Force by placing their weapons. They are focusing now on hypersonics. They are focusing on cruise and ballistic missiles, long-range ballistic missiles, and that kind of this thing. So it will be very interesting to see how our A2AD, Pakistan's A2AD, how they developed both sides within the constraints of geography that both sides have, and how within that, how we are going to fight our tactical battle. The small, that Recce strike force that I mentioned about, how we create space for our, that combat drones, you can call it them, or all that kind of drones that we are saying. So it's going to be a very, very interesting battle. And my final point is, no warfare or no operation follows the previous model. It's very difficult to this. So what, if we are trying to template now Op Sindoor, how we fought, how we'll do it, that will never going to happen. It will be something different. So we have to evolve our things in a way that we don't get surprised. We have to use all the tactics. We have to adopt all these technologies. And all the three services, I'll say, Army, Navy, Air Force, whether they are fighting that seabed, whether they are fighting undersea, on sea, on land, in the space, air, or wherever they are, on, of course, other weapons where we have to have a integrated joint air defense operations now. Thank you.
Thank you, sir. Thank you for your insight. It's very clear now that the enemy is building its capabilities, the space-based capabilities, both in the north and our western adversary, through the northern adversary's help, is coming up in a big way. I did speak here a few days ago on the wargaming, and I would like to tell to the audience that the finest example of utilization of space-based assets was in Absolute Resolve, the campaign which the Americans took to abduct the Venezuelan president on 3rd of January. The wargaming went on for 6 to 8 months, and everything was controlled from space. Whatever we are discussing here, what General Bhatt just covered, the PNTs and the other aspects. So India, in my opinion, will have to work on PNT resilience, assured SATCOM, the persistent ISR for deep precision, and rapid reconstitution, and the ecosystem approach. To speak more on these aspects, now I ask Mr. Vishesh Vatsal, CTO Skyserve, to put across his points.
Hi everyone. Yeah. Thank you so much for your time and inviting me to this distinguished panel. I'll start from what we do, and we have understood the kind of assessments that our senior figures from strategic community have made.
Speak loud.
Can you hear me?
Yeah,
Okay.
now it's better.
So So basically I'm the CTO of Skyserve, a company which is doing onboard processing onboard satellites. What we recognize is that traditionally satellite-based systems used to deliver the data to an end user in a specific latency which could go into hours or tens of hours. And let's say when we go for a few decades back, even further, much larger latencies. But tomorrow's warfare, latency will be a very important factor which decides sensor to shooter cycle times. What we have seen is that in my experience, in my limited experience, I have worked on ISR systems. So we've basically done 4 missions in space where we have processed raw data in space. What we see is that today, the adversary satellites, especially from our northern neighbors, they have the capability to have an overflight over an area of interest, able to get raw imagery acquisitions, process them, and identify targets and send them back to Earth in the order of tens of minutes. Now, this would be it would not be that much of a threat had it been a very limited observation. But this is a capability that they're introducing to most of their electronic intelligence satellites, for most of their Earth observation satellites, to most of their synthetic virtual radar satellites. We recently did an exercise internally where we looked at the exercise Trishul, where we monitored Bhuj Air Base. So we noticed that China has close to 100 satellites monitoring you. And there are very limited gaps in which they potentially don't have the capability to surveil. Now, this is one observation, that the rate at which the capability to observe us is increasing is clearly an advantage that our adversaries can have. And knowing how our space program goes, we'll obviously have some limitations in terms of the number of assets we will keep. But I feel we can overcome some of these limitations by doing much more, demanding much more of our assets. So say, for example, our assets could intelligently discard information which is not of high relevance to our end users. Our assets could do data pipelines on board satellites and also give useful information back to Earth in very fast times. In the missions that we've been doing recently, we've noticed that we've been able to process data on board in the order of a minute and are able to get useful insights back to Earth in the order of single-digit hours. And what we see is that the capabilities with ground stations and inter-satellite links coming in, these latencies would go to tens of minutes. Now, so clearly, there's the concept of smart satellites, where we have more to do with the satellites, with the limited satellites that we will have. It will clearly help us in doing ISR better. The next part that I want to highlight is there's the concept of autonomy that also is being introduced by adversaries, where traditionally, when we are asking our satellites to, let's say we are telecommanding them to task specific areas of interest, they have been done through ground passes in which the entire indenting to tasking to delivery times has a particular number of hours to days of overall turnaround period. Now, if this is the case, that's not going to help us in a future war. We need to have the capability to task autonomously. So let's say if there are let's say objects or areas of persistent surveillance, if there's an event of interest, we should be able to identify that in situ, closest to the sensing. And that's something that we have to get a feed of information. So I see that over time, the ability to do much more with our satellite assets in space will be one very critical defining factor for future wars. Thanks.
Thank you very much. And I did get a message to expedite further because some MOU has to be signed. So without taking much time, I'll request now Sree to put across her point of view before I ask the next speaker to speak. Thank you.
Thank you so much. A warm good evening to all the co-panelists, delegates, and patriots present here. It's a privilege to be part of this panel. Till now, we have heard my co-panelists detail on how the space triads builds the information high ground. The information warfare only sets the theater. I would say information is a strategic luxury unless you have the immediate responsive capability to act upon it. And true A2AD is the art of taking the right data and converting it into high-speed response before the opportunity window closes. And focusing on area denial, so in the 20th century, the decisive condition for victory was air superiority, as has always been stated. If you control the skies, you control the ground. But now, we are actively witnessing that air superiority alone is not enough. It can only work at its highest efficiency when combined with space superiority. It's about glass battle spaces, where the integration of space-based surveillance almost removes the fog of war, and the precision strikes give us the capability to eliminate threat with surgical accuracy. It has become so foundational today that without a dominant space triad, the fifth generation fighters are blind, our carrier groups are exposed, and our deep precision is simply deep guesswork. So to achieve space superiority today, we have to do more than just put satellites in the orbit. We have to deny enemy the ability to use the seams of our defenses. So we just heard in yesterday's panels, emphasizing on how this is playing out in the current Ukraine and the Red Sea right now. We are witnessing especially the democratization of denial. We are seeing how even non-state actors are using these space-adjacent capabilities, drones, commercial satellite imagery, and localized jamming to deny multi-billion-dollar assets the freedom of this moment. The main challenge is that our current A2AD defenses are static. We build exquisite satellites that take a decade to field. Our adversaries know exactly where they are, how they move, and how to blind them using reversible electronic warfare or kinetic ASAT weapons. But in the last couple of decades, area denial system has taken a great leap here. Yesterday, it was landmines and barbed wires, but today, it is integrated air defense systems. But the greatest threat I'd like to emphasize on to the current area denial system architecture, it outmatches our capabilities, the hypersonic glide vehicles. So the traditional ballistic missiles are largely predictable. They follow a parabolic arc as we know, and our radars, the arc that our current radars can calculate. But hypersonic glide vehicles, they're different. They completely skip this parabolic arc and fly at Mach 5 plus in the near space corridor specifically with unmatched maneuverability. As I was stating earlier, at this altitude, they're too low for most space-based missile warning sensors to track with precision and too high for terrestrial radars to see until it's too late. And as we know, they even underfly the advanced systems like Aegis and THAAD and overfly these traditional point defenses. So to focus on this area denial of these HGVs, we need a multi-layered sensing architecture that lives exactly where the HGV lives, in the upper atmosphere and the LEO, and also tracks these threats from birth to death, like HAPS, satellites. All of these would have to work together in nodes, feeding vital tracking information to the battle management system. We must ensure that even if an adversary takes out our primary tracking assets, we can reconstitute that capability in hours, not years. The main challenge here is that we cannot build defense against a Mach 20 maneuvering threat using simulations alone. And at the same time, we cannot afford to wait for $1 billion experiment satellite launch to see if our new X-band sensor can penetrate the hypersonic plasma sheath. We require a system that can mimic that threat and train our A2AD systems. So we are building a highly maneuverable re-entry platforms that can fly at high hypersonic speeds, that can fly at the exact profiles of a HGV, allowing us to test the interceptor seekers and HAPS sensors against the real maneuvering target in the actual environment. This gives us a platform to test the iterative interception strategies we're targeting. The thing is, how do we target a HGV? Can our present system be upgraded to intercept these threats? Or do we need to develop entirely new glide phase interceptors? And not just that, we can even reconstitute the alternative scenarios and train the integrated systems for response. Like what happens if and when a HGV takes out our important asset? How do we plan our operation around it and how fast we can respond to it? So I would conclude by saying that area denial is not a solo mission. It's a systematic symphony. And no single platform, regardless of its sophistication, can close the kill chain against these upcoming threats in this contested environment. And building a truly resilient A2AD architecture requires completely unified industrial triad where the private sectors must converge from the high fidelity sensing of HAPS and the persistent overwatch of LEO constellations to the responsive reusable launch vehicles that reconstitute our eyes in the sky. And on D-Day, our success won't be measured by individual technical breakthroughs, but by the seamless integration of these disparate nodes into one singular impenetrable web. The future of sovereignty depends on this collaboration highly, because when the first shot is fired, the only thing that will matter is how fast and collectively with this ecosystem, we can see, adapt, and deny the adversary.
Thank you, Sree. And I don't think so when this conference was planned, it would have been decided that the Honorable Prime Minister would be discussing the same, what you just said in Israel. Merging of Iron Dome, David slings and arrow for our Sudarshan Chakra. And this is the future, because to have a cover, pan-India, subcontinent, it's a big task. And we do need scaling up at a massive pace, our country. And it's nothing to do with this, but for all of you, it's just my observation that the Indian stature has gone up many a fold after Op Sindoor. If you notice, from June, July last year to now, most of the heads of states have visited India. Most of the countries are offering, without any strings attached, transfer of technology. Most of the countries are now offering to manufacture in India. We have seen massive FTAs being signed in the last few months. The European Union being the high point. The French president was here, the Russian president was here, the German chancellor was here, and we are having the Canadian Prime Minister coming next week. The Indian Prime Minister is gone, the UAE head of state was here. So the meetings are going on, and the identification of 3 private companies to manufacture the prototype of AMCA is a step for which all of you should be happy, my co-panelists, that the industry has now something to look forward to. For the first time, the government has taken the ADA approved plan and taken in Tata Advanced, L&T and Bharat Forge, to bid to make the prototype. So the space is not far. The collaborations with ISRO, DRDOs, and in many ways, for a lot of your projects which I saw down, the time is going to come when you, amongst you, would be bidding to manufacture things for our country. Without taking much time, now I hand over to the last speaker for today on this panel, Mr. Raghava K, co-founder and CEO of Sanyark Space.
Yes, sir. Thank you, sir. Honored to be part of this panel. And just as we are discussing, space has become the 4th warfare zone. And moreover, when it is giving as an integrated intelligence in terms of surveillance, in terms of the communication channel, in terms of the PNT. All these networks are very critical for when it comes to the wars. It's a dominance and deterrence, both. We have to manage both. And when it comes to the future of the wars, that things are changing. Now, a few decades ago, when we talk about the precision or a surveillance PNT, we require just meters of accuracy. Now, that's not anymore sufficient. Now the advancements in the technologies are such that we require the centimeter level accuracy in terms of the precision. And the surveillance, we need a centimeter level of imagery to understand the surveillance. And you need the communication channel, which is a quantum proof, encryption. So all these are advancements in the technologies where one another deterrence and domination, one or another we have to develop, keep on advancing. And these technologies are such that where everyone has to develop as an industry and collaboration with all the startups, and as a integrated ecosystem, it should work together. And we are developing that as part of this precision navigation and communication technologies at Sanyark space, and where we are building from the low Earth orbit based precision PNT, giving the centimeter level accuracy for the future warfare which is required, and secure communication channels that is required for the future warfare. Yes.
I have precisely 15 to 20 minutes to wind up. So I throw the house open for question and answer session. You will not get these 20-somethings to be seated and answering questions. So you have a place wherein you can ask these young budding entrepreneurs what lies ahead and how we could collectively take our country ahead in space domain. Please feel free and ask questions. It's open to everybody.
So Vishesh, thank you for this thing. I just want to ask you that whatever you're doing now, what type of AI enablement, or what is it? How are you going to give the end product based on satellite itself, which you're talking about? Because you need a lot of library for that. Our image interpreters would be doing their own work. Do you have access to that? I mean, how do we, as users, say that the thing coming from you is mill grade and absolutely reliable? That's one. And ma'am, to you, basically, as I understood, you're having a re-entry hypersonic thing, so we can, train our equipment, whatever we need to do further on that. So, but it's a whole lot of a system in place from sensors to thing. So how do you see that little portion of what you are developing is going to be in the larger picture of the thing? Right? Thank you.
Okay, on the question of AI, I've done some thinking on this, and also we've worked with strategic users as well as entities like ISRO. So one of the first admission is that, to be very transparent, it's very hard to trust what an AI model gives you. A lot of these models are probabilistic in nature. A lot of these models are trained on curated data sets, which are nice, but when you look at real, what we call as production data, they oftentimes fail. And it's the nature of these models to be of this form, but these problems last only till the models have seen enough real world data. So what we have noticed is that, for example, the work that we do, where we have used computer vision models or deep learning models in space, the data sets that are there, they are very cloud free, they're not having that much noise and so on. When we look at the in-orbit raw data, they're extremely different. So these are things that we basically work on internally to annotate it ourselves and kind of look at how do we pre-process such data to increase the confidence. That being said, it is still a probabilistic inference. The way to look at this is the amount of information, let's say a very good model retains, is very high, and its precision can increase to a significantly high number given enough amount of training data. The another way to think about it is we have to do enough real world validation as well as having causative systems to have some explainability. Now, let's say if the inferences that our models make, in our case, satellite imagery, we have to verify by clear questioning, say, for example, by post-processing, by continuous validation, that are these models are improving enough at the rate that you're expecting, because tomorrow the amount of data that's going to land to us would be in the order of terabytes a day. The rate at which Earth observation is projected to grow is going to be a few thousand terabytes a day in the matter of 5 to 10 years. So it's not that the data will be a problem forever, and the companies or say the entities who are working on such models, if they build very strong metrics to accept the conditions at which these models work, that would get you to some level of confidence. But at the end of the day, there's nothing replaces the experience of a user who has got exact context of what they're trying to interpret. And basically, here's where collaboration works, because let's say folks from us who are in the industry, we may not realize the significance of a specific part of a model until we work with yourselves. So I think over time, as these collaborations increase, this will have our native indigenous models which could work to our acceptable precision.
Yes, to answer the second part of the question, on the bigger picture, to be able to develop area denial for hypersonic glide vehicle, we will require a complete multi-layer strategy. But the point where I'm coming up with this re-entry vehicle is that this will, the moment hypersonic glide vehicle comes in, even for a single target, it's capable of taking multiple paths. So with this re-entry vehicle, during the return, it goes up to Mach 20, and it will provide a platform that will mimic the HGV, with which we can train our interceptors and operation systems. That is on the one hand. And on the second end, we'll also be able to test and validate our sensors and material systems also. So this will be the platform to increase our TRL, do iterative testing on the first hand, which will accelerate these defense systems. So that is where this re-entry vehicle will play a role in developing the area denial over HGVs.
Anybody else?
So, what you've spoken, where is the TRL of this technology that you're working on?
Currently, we are in TRL 4 demonstrating the precision landing capability and guidance and navigation system, which is a key element for the re-entry part of it. The demonstration of it are ongoing, and the campaign will go on for the next 3 to 4 months. And post that, within the next year, we'll be doing an orbital re-entry demonstration also.
Anybody else? Okay. So, end of the day, 5:30. Pannu sir, we are on time. I was told that we have some MOU to be signed and some distribution of mementos. So, so this is precision. Summing up PNT talk, a few points which came to my mind for India-focused approach of this discussion. That is how India should design the counter A2AD space architecture is one. What lessons can India draw from the recent conflicts? We have covered a few, and the one which I feel everybody should go through is absolute resolve of 3rd Jan this year, where 150 fighter aeroplanes got airborne from 20 different air bases, with each and every US agency involved, be it in uniform, be it in civil, and monitoring the real time. And without even a single shot being fired through space and cyber, they could take out the Caracas electric supply. They, took out the Chinese and the Russian air defense equipment without firing a single shot. And this was, capable. This is the precision that the future wars will take on. So is India institutionally ready for joint space operations along the 3 services? In one more question, which we can leave it for some other day. The future war scenarios throw up certain aspects, which I just thought we will leave you with certain thoughts before we end up today's program. Is counter space, how will counter space weapon, cyber attack on satellites, and electronic warfare shape the opening parts of conflict? We just covered one. Does AI-enabled space ISR risk strategic instability by reducing warning time? And lastly, are we prepared for space as the first contested domain in the future wars? So with this, I close today's session, and I wish to thank Mr. Rao, General Pannu, and the complete team who have worked tirelessly, and it is an annual event which is widely looked forward to all the people who are distinctly and nearly and completely associated with space and space-based applications in this country. I wish to place on my record my sincere thanks to each and every organizer here, and thank you to the fellow panelists who have come from far and wide, and it's nice to share with 20s and 30-somethings on the stage, and it's a good going, and that's the way the country will move ahead. Thank you.
Thank you very much indeed, sir. And now, ladies and gentlemen, for that formal MOU exchange, I would like to invite on stage our distinguished representatives from Take Me to Space, Hyderabad, and Little Place Labs, Houston. This MOU is for building a constellation of indigenous high-performance compute satellites, effectively data centers in space. Little Place Labs has developed Orbitify, an edge AI platform. You may kindly come here behind the panelist. AI platform under US Space Force funded program delivering near real-time alerts for national security and commercial applications. Together they will provide defense and intelligence agencies advanced capabilities, including aircraft and vessel detection, classification, and change detection in sensitive areas on a near real-time basis. And may I now request for the MOUs to be exchanged in the august presence of our distinguished panel and all our distinguished dignitaries present here. Let's put our hands together for them. As I request our chair and moderator, Air Marshal Sanjeev Kapoor, to kindly do the honors of, can we have a group photograph, sir? Can we request you to join? Can I request Mr. Anil Prakash, Janal Panu, Mr. Subarao Pavaluri to kindly come up, sir, for the MOU exchange. You can join the photograph. Can we request the panelists to join our dignitaries for a group photograph, please? And requesting Air Marshal Sanjeev Kapoor to kindly felicitate our dignitaries. We present to Lieutenant General A.P. Singh, we present to Mr. Vishesh Vatsal, to Ms. Sree,
Vishesh, please come. Your parents' name do aptly.
Ms. Sree, Supranayi, and Mr. Raghava K. And I would request Mr. Subarao Pavaluri to kindly do the honors of felicitating Air Marshal Sanjeev Kapoor. And ladies and gentlemen, with that we quickly close the proceedings and would request everybody to kindly move out from the venue as soon as possible if you do not want to get stuck in the security protocol and be seated here till 7 o'clock. So with that, thank you very much indeed for all your cooperation. And tomorrow morning, ladies and gentlemen, once again, we begin the proceedings at sharp 9:30. And Mr. Anil Prakash has an announcement.
Thank you very much for your patience throughout the day. We have a reception tonight at 7 o'clock at Charger Bar. Those who wanted to stay back and enjoy, you can move down to Charger Bar now. And we will start that in the next maybe by half an hour or 40 minutes. So you can vacate this place and you can move down to Charger Bar. Thank you very much.
We last met in Australia.
Yes.